All right, everybody, get ready because today we are taking a deep dive into the world of GPUs.
Yeah.
These little chips that are, well, they're way more than just for gaming. You might think GPUs, what's the big deal?
Right.
But stick with us because this is going to get really interesting. We're talking about everything from AI to those crazy realistic simulations you see, even how those YouTube videos render so quickly.
Yeah, it's wild.
We're going deep on IBM's explainer on GPUs today.
Okay.
And you got to hear this analogy. Imagine one single chef trying to make this huge, elaborate feast versus having a whole team in the kitchen.
Yeah.
That's kind of like your CPU versus a GPU.
It really is. What's so cool is how GPUs went from this like niche thing for tech people to something that's in almost every industry now.
Yeah.
It's been a crazy journey from where they started.
It all goes back to the 90s, right? Video games were getting more and more realistic looking, but the tech was having a hard time keeping up.
Exactly. This is when computer graphics were becoming way more complex and the CPU, which is like the brain of your computer, was getting overloaded. CPUs are good at multitasking, but the kind of parallel processing you need for those early graphics. It's like, imagine trying to water this whole field of crops with just one watering can.
Oh, wow. Yeah.
So inefficient.
That's where GPUs came in to save the day.
Yes.
Like swapping that watering can out for a whole irrigation system.
Exactly. GPUs offered this specialized processing power just for those complex graphics computations. It made everything faster, smoother, and it freed up the CPU to handle everything else since the GPU was handling those graphics.
So games got more immersive, more realistic.
Yeah.
But it doesn't stop there, right?
Nope, not at all. It's like GPUs went from like line cook to head chef,
Right.
capable of so much more. This is where things get really interesting. The big turning point was when NVIDIA introduced CDA back in 2007.
CUDA. Okay, break that down for me. Sounds a little intimidating.
So CDA stands for Compute Unified Device Architecture.
Okay.
And it was a huge deal because it let developers use GPUs for way more than just graphics.
Oh, interesting.
Before CDA, GPUs were kind of stuck in their own lane, limited to just a few tasks. CDA broke down all those barriers. It let developers really use the power of GPUs for general purpose computing.
So instead of just making those pretty pictures, they figured out how to use GPUs for tons of other stuff.
Yeah.
So what came next? This is where AI comes in, right?
Exactly. The 2010s saw the rise of ray tracing, which made graphics even more realistic by actually simulating how light works in the real world.
Wow.
And then you've got tensor cores, which are designed for those deep learning algorithms that are super important for AI.
Hold on. Deep learning algorithms. I think we got to unpack that a little bit.
Right, yeah. It's easy to throw these terms around.
Yeah.
Essentially, deep learning algorithms are a type of artificial intelligence where computers learn to see patterns in massive amounts of data.
Okay.
It's like, imagine teaching a computer to recognize a cat in a photo, but on a way bigger scale.
Gotcha.
Yeah.
Okay, so we've got GPUs doing these photorealistic graphics, empowering AI, what a glow up.
Yeah.
So these tensor cores, they're like giving GPUs this whole other set of skills, right?
Yeah.
Like now our head chef can also bake like a pastry pro.
Exactly. Tensor cores are amazing at matrix multiplications, which are key for deep learning. It's what makes them so efficient at training those AI models we were talking about.
That makes sense. Now, IBM's explainer mentioned there are different types of GPUs, like discrete, integrated, virtual. Can we break those down a bit?
Sure. It's kind of like you wouldn't use a professional chef's knife to just chop up some veggies for a quick salad, right? Different GPUs have different strengths for different tasks.
Okay, so for everyday users, like my friend who mostly just browses the web and watches cat videos, what kind of GPU are they rocking?
They probably have what's called an integrated GPU.
Okay.
It's built right into the CPU, which makes it really cost-effective and energy efficient for like everyday computing. It's like having that handy all-purpose knife in your kitchen drawer.
Gotcha.
Perfect for most things.
Okay, and what about someone like me who may or may not spend a slightly embarrassing amount of time gaming?
Well, you'd want a dedicated or discrete GPU.
Okay.
These are separate cards that are specifically designed for like really high performance graphics processing. That's your professional chef's knife,
Right.
designed for precision, handling those demanding tasks.
Got it. Now, virtual GPUs sound kind of interesting. What's the deal with those?
So virtual GPUs are software-based, so they offer a ton of flexibility.
Yeah.
It's kind of like if you were to rent out a super high-end kitchen just for a big event instead of buying all the equipment yourself.
Oh, okay.
This is perfect for businesses that need to be able to scale their processing power up or down without making those huge investments in hardware.
That makes a lot of sense. It's pretty incredible how GPUs have become so crucial in so many different areas. We've talked about gaming, AI, but what about their impact on other industries? IBM mentioned their Vela supercomputer, right?
Yeah, Vela is a great example of how GPUs are being used to really accelerate cutting-edge research. Because they can do that parallel processing, they're able to crunch these massive data sets for things like developing new materials or even drug discovery.
That's amazing. So we're talking about everything from speeding up video games to potentially like curing diseases. That's a pretty big range.
It is.
But let's bring it back down to earth for a second.
Okay.
How are GPUs changing the game for content creators like YouTubers, graphic designers? I feel like video editors especially are always raving about GPUs.
Yeah, and they have every reason to. GPUs have completely changed content creation, especially video editing. Remember when you would start a render and then you'd basically have time to go write a novel while you waited for it to be done?
Ugh, don't remind me. Those render times were brutal.
I know, but now GPUs can cut those render times way down.
Wow.
They're also essential for live streaming, 3D modeling, animation, anything that requires a lot of processing power, even those AI-powered tools that can, like, upscale your old photos, all fueled by GPUs.
It's like having a whole team of editors working on your video at the same time. So we've got faster editing, more realistic graphics. What else is on the horizon? What about these simulations and visualizations that IBM was talking about?
Right.
This is where it feels like we're really stepping into the future.
It really does.
It's like that scene in a sci-fi movie, right?
Yeah.
Where they step into that holographic projection.
Yeah.
But this is real life.
I know, and because GPUs can handle so much data, these simulations are just getting more complex and detailed all the time. We're talking about being able to, like, predict weather patterns, see how new drugs would work, even recreate historical events super accurately.
Wow. So from, like, entertainment to groundbreaking research, GPUs are pushing the limits of what's possible. It's crazy how these little chips went from just, like, boosting video game graphics to having this huge impact on all these different fields.
It really all goes back to that parallel processing, you know? That ability to do millions of calculations at the same time. That's what makes GPUs so powerful, and is why they're so perfect for these really complex jobs.
It's like the difference between, like, a solo chef trying to cook 1,000 meals versus having a perfectly synchronized team of chefs in this massive kitchen.
That's such a good analogy. And just like in a well-run kitchen, those software developers are getting so good at using the power of GPUs to make amazing things.
Okay, so before we wrap things up, let's do a little head-to-head here.
Okay.
GPU versus CPU.
Okay.
What are the big differences? And why can't we just have one that does it all?
Well, it's not really that one is better than the other. They're just made for different things. Think about the CPU like a Swiss Army knife, you know?
Okay, go.
It's great at handling a bunch of different tasks, but it might not be the absolute best tool for every single job.
So the CPU is like our multitasking chef, but the GPU is the specialist.
Exactly. The GPU is like, if you have a super high-powered food processor, you know?
Okay, yeah.
It's amazing at handling huge amounts of data all at once. So CPUs are good at running things like your operating system, your apps, and then GPUs really come in when you need that heavy-duty processing, like rendering graphics or training those AI models.
So they both have their strengths, and often they actually work best together as a team, just like our chef and our food processor.
Exactly. And as developers keep figuring out new ways to combine those strengths, we're going to see some truly mind-blowing advancements in the future.
All right, so there you have it, everyone. GPUs. From giving you those epic gaming moments to driving these huge breakthroughs in research, these little chips are shaping the future in ways we couldn't even imagine before.
The possibilities are endless.
That's for sure. And with that, we're going to wrap up this deep dive into the world of GPUs. If you're as fascinated by this tech as we are, definitely check out the show notes. We'll have links to IBM's full explainer, along with some other resources so you can keep learning. Thanks for tuning in, everyone.